All right, in this video here, we're going to take a look at a higher degree equation that's in what we call a quadratic form, right? It's not a quadratic equation, but it's in the form of a quadratic equation. So if we do some little trickery here, we're allowed to use the methods for solving a quadratic equation, even though this equation we have is actually an x to the fourth power, right? So the equation we have is x to the fourth power minus 5x squared plus 4 equals 0. Right, so whenever we have an equation in this form, and the form I'm talking about here is that first x is raised to an even power, right? 4 is an even number. The x in the middle is raised to half of the power of that first one, right? So if this is a 4, this one over here is a 2 because 2 is half of 4, and then this last term we have here is a constant. We call that a quadratic form, right? Because in a quadratic equation we have an x squared, we have an x to the first power, and then we have I'm going to put a c for a constant, some number. Right, so that's what a quadratic equation looks like. So, an even exponent to start, half of that in the middle, and then a constant. So another example of a quadratic form would be something that has an x to the sixth power, and then an x to the third power, and then a constant. Right, an even exponent, half of that in the middle, and then a constant. Or I could have something like this, like if I had, let's say, x to the 14th power, and then an x to the 7th power, and then a constant. That's also in that quadratic form, right? Even, half as much, constant. Anytime I have an equation that's in that form, I can treat it like a quadratic equation, and then I can use factoring, or I can use the quadratic formula to actually go ahead and solve the equation. All right, so let's do that for this one that we have up here, which has the fourth power, and then the second power, and then the constant. All right, so what we do in order to treat this as a quadratic equation is we make a substitution of a variable, which when you first see something like this, it can be a little bit confusing as far as what you're actually doing here, but it is a method that you will use, a little bit in pre-calculus. You'll use it kind of a lot when you get into calculus. Maybe not a lot, but you'll use it fairly often when you get into calculus as well. Substituting a variable to make the variable more convenient to work with. Right. So what I'm going to do in this case is, for the x, whatever my middle term is, that variable there, that x squared, I'm going to substitute that. I'm going to say, let w, I just picked some other letter besides x, so I'm just going to pick a w. Let w equal x squared. Right, so in place of the x squared, I'm going to put a different variable, which I'm just going to call w. Right, so let w equals x squared. Well, if w is equal to x squared, then what is x to the fourth in terms of w? Well, x to the fourth, that's x squared squared, right? So if w equals x squared, then x to the fourth is going to equal w squared, right? Because if I do x squared, if I square that, or think about it, if I square both sides of this equation, I would have w squared here, and then x squared squared, a power to a power I multiply, and I get x to the fourth, right? So back to my original equation now, if I make that substitution of the variable, in place of x to the fourth, that's going to be my w, my new variable, squared. Right? Minus 5, instead of x squared, well, x squared is just w. Minus 5w, and then plus 4 equals 0. And when I make that substitution of variable, now I have a quadratic equation. Right, now it's w squared minus 5w plus 4. It's a second power, a first power, and then a constant. And now I can factor this or use a quadratic formula to solve it, because now I've turned it into a quadratic equation. Right, and if you had one like this, like I mentioned before, like if you had an x to the sixth and then an x to the third and then a constant, you would make your w equal to x to the third, and then this would turn into a w squared, this would be your w, and then that would be your constant. Right, so when you have it in this form where it's an even exponent, half of that, and then a constant, you make your variable substitution for that one that's in the middle, and then the one in the front becomes that w squared, or whatever letter you choose, squared. All right, so that's what we call a substitution of variable. Like I said, it comes up every once in a while when you get into calculus, a little bit in pre-calculus, but definitely more often when you get to calculus. So something important to understand what's going on there. All right, so I made my substitution. Now I have a quadratic equation, w squared minus 5w plus 4 equals 0. So now I have options to solve. I have possibly factoring. The square root method won't work here because of this 5w in the middle, or I can use the quadratic formula. This one, though, looks like I can factor it. The numbers are pretty small, and I can think of two numbers that multiply to positive 4 and add up to negative 5 with that 1w squared at the beginning. So let me just go ahead and factor this. Right? And if you weren't able to factor it at this point, you would then go ahead and use the quadratic formula to try to solve it. Right? So the w squared I split up into w and w, right? Two numbers that multiply to positive 4 and add up to negative 5 are going to be negative 4 and negative 1. Right? When I multiply those two negatives together, they equal a positive 4. But when I add them together, they add up to that negative 5. Right? And then still equal to 0. And now that I factored it, I separate my factors. And now I'm just solving this just like it was a regular quadratic equation. Although there'll be a little bit of a difference at the end here. Right? So w minus 4 equals 0. When I solve that, I get w equals 4. And I have w minus 1 equals 0. When I solve that, I get w equals positive 1. All right, so there's the two solutions to my quadratic equation. But remember, this quadratic equation here, this w squared minus 5w plus 4, that's not what we were trying to solve, right? We started off trying to solve x to the fourth minus 5x squared plus 4 equals 0. Right, so how do these numbers here for w give us the solutions to that equation up there? All right, so let me erase some of this stuff in the middle here, and we'll figure out what x is equal to, right? Remember, since our original equation was equal to, or the variable in our original equation was x, we're not done until we say what x is equal to, right? If this is my equation, x to the fourth minus 5x squared plus 4 equals 0, and I say the solution is w equals 4, that doesn't make any sense, right? W is not the variable that we had in that original equation. Right, so I go back to my definition here. W is equal to x squared, right? So if w equals 4, that means that x squared is equal to 4, right? So I substitute this x squared back in for the w, so I get x squared is equal to 4. And then for this one here, for w equals 1, I do the same thing and I get x squared equals 1. Right, so in order to make this a quadratic equation and factor it or use the quadratic formula and solve it, I had to take out that x squared and replace it with a w. But once I solve it, I put the x squared back where that w was. Right, so when I have w equals 4, I put the x squared back for the w. And same for the w equals 1, I put that x squared back in. Right, so I just make that change in variable just for a brief period of time, just long enough to allow me to work on the problem and solve it in a convenient way. But then I always have to substitute back that original variable that I started with, which is what I'm doing here, substituting that x squared back in place for the w. Right, and once I do that, now I can solve for x. Right, so if x squared equals 4, well, to solve this for x, since it's x squared equal to a number, I can use the square root method and take the square root on both sides. Just remember, when you use the square root method, you have to put that plus or minus in front of the answer. So I get x equals plus or minus 2, right? Because the square root of 4 equals 2, well, positive or negative 2. And same over here, for x squared equals 1, if I do the square root on both sides, I get x equals positive and negative 1. Right? Those are my solutions to this original equation, x to the fourth minus 5x squared plus 4 equals 0. All right? Notice, when we have quadratic equations, usually we end up with two solutions. Here I have what we call a quartic equation. It's an x to the fourth power. I actually get 4 solutions to that. Positive 2, negative 2, positive 1, negative 1. That's 4 answers, right? It's one of those rules of algebra that whatever your highest exponent is, you can have up to that many solutions, right? So if I have an equation that involves an x to the fourth power, I could have up to 4 solutions to that. I don't always have 4. I could have less than that, but in this case, I get all 4 of those solutions. Right? If this was an x to the sixth power, I might get 6 solutions to that equation. All right. So that's solving an equation in a quadratic form. You substitute a variable. In place of the x squared, I put a w. That changes the equation to a quadratic equation. Then I can factor or use the quadratic formula to solve it. And then just make sure after you do that, you substitute your original variable back in, and then solve for that x or whatever that original variable is when you're done. All right, so that's something that's in a quadratic form. And again, doing that substitution of variables is something that comes up once in a while when you get into higher level math. Sometimes the equation you start with or the problem that you start with is too complex, but if you substitute a different variable in there, it makes it a little bit easier, like what we saw here.